Welcome to Engineering Statics. This is ENGR ampersand 214, taught at Bellingham Technical College. This is a really quick lecture on scalar vector product combinations. We've already gone over the vector product or cross product when we want to find something perpendicular to two vectors, the sine of the angle between, and of course with both magnitudes included in that product. We have the dot product, which gives us the portion of something parallel to something else and involves the cosine of the angle between two vectors. It's of course a scalar, not a vector. So what happens if you have combinations of them? Can you? And maybe where would we use them looking ahead? So we're gonna start with a couple of named products. These have gotten names because they're used a lot. We'll start with something called the scalar triple product. And it's called the scalar triple product because we multiply vectors the same way we do any other number, any variables. We start within the parentheses, evaluate that, get, in this case, a product, a cross product, and then we multiply that by dotting another vector into it. So the overall product is a scalar because we end up dotting a vector into another vector. So a vector dotted into a vector is a scalar. It's the dot product. Okay, so we can apply the distributive property to this basically, and as long as we don't reverse the order, so we have to be very careful about that. So we can distribute C dotting into A and B, and we can change order as well. So just remember that A cross B does not equal B cross A. So that is a useful trick if we needed to say figure out which portion of a planar normal was parallel to something else. And in this case we might also very strictly use a cross product to determine a torque of a force about a point, and then figure out which portion of that is itself parallel to an axis. This particular scalar triple product gives us the magnitude of a torque or about a line or about an axis from a given force. So we definitely have a use for that, which we'll see later on in the definition of moment about a line. And remember, parentheses give the order of operation, just like anywhere else. So here's a couple of examples with just vector notation that you can work through just to keep your signs straight. And of course when we get to moment, we'll be doing this with real forces and radii from points and lines. Okay, we can also define a vector triple product. So we can take the cross product of two vectors, get another vector, and then cross that into another one. So no specific applications for that, but know it's possible, and as was the case in any kind of cross product order that would involve a change of a parentheses recombination that would give us a change of order is not allowed. So because the cross product is not commutative. So in this case we can't apply the associative property and just change the order of operation, move the parentheses. You'll find that in this case we end up getting the wrong answer. So we can just use some unit vectors and try that out and find that they don't equal the same thing. And that's just because we end up doing something in a different order, and we end up getting that negative commutative property. So you can't apply the associative property to the vector triple product. You have to evaluate what's in the parentheses first, then cross this. You can't change the order. Sorry. And that is it for what's called the scalar and vector triple products. So basically, points to remember in both cases: evaluate what's in the parentheses first, work in to out like any other algebraic kind of property. We can apply the distributive property for the scalar triple product. We cannot apply the associative property to the vector triple product, or we get the wrong answer. So we have to evaluate what's in the parentheses first as given. So that is it, and you will definitely be seeing the scalar triple product to calculate moment of a force about a line. That's it for our very quick mini lecture.